Alright, so the notes for today are section 14.0, which is 0 and negative exponents. And so we added this section in so that we could give a little bit more practice with some of the properties of exponents that this new unit will expect you to know. So in the first, go ahead and write down the learning target. And then in the first example, it says complete the tables below, check your answers using a calculator, write your answers as fractions, not as decimals. So we're going to make sure we write our answers as fractions. Y equals 2 to the x means that all of these numbers for x are getting plugged in as the exponent. And so you can use your calculator to help you. I'm going to start out over here and do the positive side first. So 2 to the first is equal to 2, 2 to the second is 4, and 2 to the third, remember that's 2 times 2 times 2, is equal to 8. When you plug in 0, any number raised up to the power of 0, if you plug this into your calculator, it gives you a positive 1. And that's actually going to be true for any time you put a 0 in for an exponent. You're always going to get the number 1. These numbers cause the value of the fraction to flip to the other side. So when you plug in the negative 1 for the 2, it doesn't mean your answer is negative 2. It means your answer moves to the bottom of the fraction. And same thing, when you plug in a negative 2, the 4 moves to the bottom of the fraction. And when you plug in a negative 3, the 8 moves to the bottom of the fraction. So anytime you have a negative exponent, it causes the value of the fraction to flip, or it causes that value to move to the denominator of your fraction. The same is going to be true when we fill out the numbers in B. So let's see, 10 to the first is equal to 10. 10 squared is 100, and then 10 to the third is 1000. So I'm just plugging in the exponents for those. 10 raised up to the 0 power is equal to 1, and you can confirm that with your calculator. And so for these numbers, when I plug in a negative 1, it just moves the 10 to the first down into the bottom. When I plug in a negative 2, it moves the 100 down into the bottom. And then when I plug in a negative 3, it moves the 1000 down into the bottom. And so that gives me my values for each of the problems in B. So there are three things happening in examples A and B. It says, what do you notice about having 0 as an exponent? Anytime a number has 0 as an exponent, it always equals 1. So 4 to the 0 equals 1, 5 to the 0 equals 1, 6 to the 0 power equals 1, 7 to the 0 power equals 1, and then this one's kind of random. It's just random on purpose to show it doesn't matter. 857 raised up to the 0 power would also equal 1. If you have a negative exponent, it means that the value of the base, or with whatever the exponent would be if it were positive, moves to the other side of the fraction. So 4 to the first power would be 4, so 4 to the negative first power turns into 1 over 4. It moves the value of the expression down into the bottom of a fraction. 5 squared would be 25, so when 5 to the negative 2 moves into the bottom, it becomes 1 over 25. This one would be 1 over 6, because it's 6 to the first. This one would be 1 over 49, because it's 7 to the negative second power. 7 squared would be 49, and the negative on the 2 moves it to the bottom. And then 857 to the negative first power would be 1 over 857. So if the negative exponent was on the number in the top, it moves it to the bottom. That means that the opposite happens here. If the negative exponent is on a number that's in the denominator of the fraction, it does the same thing, but then it moves it up to the top. So the 4 in this one would move up to the top. It would be 4 over 1, which would just be 4. The 16, because 4 squared is 16, the 16 in this one would move up to the top. Notice that none of the numbers, by the way, are becoming negative numbers. The negative on the exponent is just making us move the number. This one would be a positive 5 up in the top of the fraction, and then 5 squared is 25. It's in the bottom, but the negative on the 2 would move it up to the top. So a negative on an exponent means that the number has to move. So we're going to summarize the rules from above into this table so that you have an easy reference point that you can refer back to when we're practicing the problems on the back of the notes. If a number is raised up to the power of 0, it always equals 1. It doesn't matter what this number is. And then these two rules were what we practiced up above in D and in E. And so I used a kind of bracket here to show you that both of these descriptions describe both of these. A negative exponent indicates that the expression is not fully simplified. The base with the negative, so the part that has the negative exponent, needs to be moved to the other side of the fraction to simplify it. And then I want you to add this onto your notes down here at the bottom. Again, feel free to pause the video so that you have time to write this down, and then make sure that you read it over and make sure you understand it before you move on to the next part in the notes. It says negative exponents don't make the number negative, they mean that that part of the expression needs to be moved to the other side of the fraction. So either from the top to the bottom or from the bottom to the top. You need to have the opposite be done. And so in the next page of the notes, we're going to practice simplifying expressions where there's different parts. Some of them need to be simplified and some of them don't. And so this will help us with how to simplify the ones that we're about to do in the next part of the notes. Alright, so in the back section of these notes, starting with number 2, you want to go pretty slowly through these to make sure that you understand how they're changing. So feel free to pause the notes video or rewind if you need to hear something described for you again. Remember that the negative on an exponent moves the number that it's connected to down to the other side of the fraction, and then if it's possible to simplify it from there, you would. So 3 to the 4th, 3 times 3 times 3 times 3 is 81, but 3 to the negative 4th means that that 81 gets moved down into the bottom of the fraction. So the final form for that would be 1 over 81. I like to use the circling and pointing to show how the numbers are moving. On the next one, it's just the 5 that has the negative 2 attached to it. So the 5 squared is going to move down into the bottom of the fraction. 5 squared is 25, so when it moves to the bottom, the exponent acts on the number the way that it would. What's different about this one, though, is that you still have the 2 in the top, so it's not 1 over 25, it's going to be 2 over 25. Again, the 2 didn't need to move, but the 5 did. So these are the final answers for these questions, by the way. The next one, anything raised up to the power of 0 is equal to 1. So that's the final answer for that one. And then on D, anything raised up to the power of 0 equals 1. So the bottom on this one would turn into 1, and then 1 divided by 1 would give you 1. And so that would be the final answer for that one. So I guess you could put equal signs on all of these if you wanted to. When the number that's in the base is a variable, the same thing happens. It's just the number's not going to change, like a 3 turned into an 81 or a 5 turned into a 25. So on this one, the x needs to move down into the bottom of the fraction. It's going to turn into 1 over x to the first, which would just turn into 1 over x. You don't need to put the 1 here. If this were a number besides 1, though, then you would write that exponent right here. All right, on letter F, the 9 can stay. N to the 0 equals 1, but the m squared has a negative exponent, and so that's the one that needs to move down into the bottom of the fraction. The 9 stays in the top. The n to the 0 power goes away because anything raised up to the power of 0 equals 1, and then the m squared moves down into the bottom. One thing that I want to note here is that when the base moves down into the other side of the fraction, the exponent that was negative becomes a positive exponent. So it doesn't stay negative 2, it turns into positive 2. On the next one, the 8 can stay, the x can stay, but the y needs to move down into the bottom of the fraction. So this one's going to keep the 8 and the x in the top, but then be careful, it's not going to be y to the negative 5, it's going to be y to the positive 5 in the bottom of the fraction. Anything, even something gross like this, raised up to the power of 0 is equal to 1. So the answer for this one is just regular 1. And then each of the ones in the following row just has a little bit something different about it. Let's look at letter I. The part with the negative exponent needs to move to the other side of the fraction. So on this one, the b to the 9th stays in the top, and the a to the 3rd moves down into the bottom. And again, when the base moves, the part that has a negative exponent on it, the negative exponent changes into a positive exponent. On J, let's see. This part needs to move up into the top to clear out the negative exponent. So the x to the 4th is going to move up into the top. The other thing that changes on this one is that 10 divided by 5 can simplify. 10 divided by 5 turns into 2 over 1. We don't need to write the 1 in the bottom of a fraction. And so our answer for this one is just 2x to the 4th. 2 because 10 divided by 5 is 2. And then x to the 4th because the x to the negative 4 in the bottom needed to move up until the top. On letter K, this one needs to move into the bottom, this one needs to move into the bottom. The 8 doesn't have to move though, so the 8's going to stay in the top. And then z to the 0 in the bottom means that this equals 1, so this part will go away. But these two will slide down into the bottom. So we're going to have an 8 in the top, and then an x to the 5th, positive 5 on the x. And then it would be y to the positive 1, but remember when the exponent on something is a 1, you don't have to write it. The last one, the 3 needs to, draw that all the way across. The 3 needs to move into the bottom, the 3 to the negative 2, and then the b to the negative 8 needs to move down into the bottom. The a to the 4th does not need to move because the exponent on it was a positive 4. So I've got a to the 4th up in the top. 3 squared, when it moves down into the bottom, it's going to be 9. And then the b to the negative 8, when it moves down into the bottom, the negative 8 is going to turn into positive 8. And so that would be the final simplified answer for that question. If the number 3 was something bigger, or if the exponent was bigger, you could leave it not done out. So like 3 squared is 9, I changed it into a 9. But on this one, 3 squared is such a small number that it would be expected that it would get multiplied out, just like this one did. This section feels a little bit random when you compare it to what we just did, but we wanted to make sure we put into the notes some formal examples of what happens when your exponent is on a negative number. So when you have negative 4 inside parentheses raised up to the 2nd power, negative 4 times negative 4 is positive 16. It's different when there's not parentheses around the number. This means you square the 4, but then the number stays negative. So this one's actually negative 16. Negative 4 to the 3rd power means negative 4 times negative 4 times negative 4. So that's negative 64. And then if you do negative of 4 to the 3rd power, that's also negative 64. Let's see, in the next row, the numbers are a little bit bigger. So again, we'll use a calculator to do the multiplication with this. Negative 7 raised up to the 4th power means negative 7 times negative 7 times negative 7 times negative 7. So that's positive 2,401. If it's not inside parentheses, it means that you get the 2,401 from doing 7 to the 4th, but then it stays negative. And then if we do that big number up to the 5th power, let's see, there's an odd number. So positive, negative, positive, negative, positive, negative, positive. There we go. So this one's going to be negative 12,005. Let me just check the multiplication on that. Times 7. Just kidding. I multiplied that wrong. It's negative, but it's 16,807. That's what you get when you do it to the 5th power. And then on this one, it's also negative 16,807. So you might be starting to see the pattern that's developing. If the exponent is an even number and the number is negative, it comes out to be a positive number when that negative is inside parentheses. If it's an odd number exponent, it doesn't affect the answer because the answer is going to be negative either way. Notice on this one, the 4 was an even number. So if the negative was inside parentheses, it was positive. And if the negative was, if there were no parentheses, it's negative. And then again, on this one, it was an odd number, 5. So it didn't matter. Both of them worked out to be negative 16,807. So on this one, if I have an even number of negative 1s being multiplied by each other, I'm going to get positive 1 as my answer. But on this one, it makes it negative afterwards. So that one would be negative 1. And then this would be positive 1, and this would be negative 1. Anything raised up to the power of 0 equals 1, so that's why this one turns into a 1. This one says anything raised up to the power of 0 equals 1, and then the negative out front turns it back negative at the end. So it matters whether you use parentheses or whether you don't use parentheses, whether you use parentheses or whether you don't use parentheses with a negative number when it's being raised up to an exponent. Question number 4 wants us to complete the table based on the values. And so in the first one, you're doing negative 4, and then you're raising it up to the negative first exponent. Remember that a negative 1 on the exponent flips the number to the other side of the fraction. So if I started with a negative 4, and if I did negative 4 to the negative first power, it's going to turn it into 1 over negative 4, so it flips the number to the other side. If I finished with a negative 2, that means that I would have had to have started out with a negative 1/2, because again, the negative 1 on the exponent, it would flip this number that's in the bottom up to the top of the fraction, and so that would turn it into negative 2. If I finished with a positive 1/4, that means I would have needed to have started with a positive 4, because again, the negative 1 exponent would flip this 4 down into the bottom of the fraction. If I started with a 4/5, and if I raised it up to the negative first power, this 4 would move into the bottom of the fraction, and this 5 would move into the top of the fraction. So raising a fraction up to a negative first exponent basically just takes the fraction and flips it upside down. The last one's given to me as a decimal, which is kind of hard to understand, so most people prefer to take this one and turn it into a fraction to help them understand it. If you finish with 3/4, and if the negative 1 flipped everything upside down, that means that the 4 would have had to have started out in the top, and the 3 would have had to have started out in the bottom. So in summary, what question 4 is having you do, it's helping you recognize that putting a -1 exponent on something basically just makes the fraction or the number flip. So it moves to the other side of the fraction. Alright, the last section in the notes says that you have a population of bacteria that doubles every hour. The number of bacteria is modeled by it's actually an equation, but this is the equation where H represents the number of hours after a scientist measures population size. And so the first one wants us to evaluate the expression for f of -3. And so to find f of -3, we're going to take -3 and plug it in for wherever there was an h. So it's 1,000 times 2, and then we'll plug in a -3. Remember what a negative exponent does? It flips that number into the bottom of the fraction. So that's going to give you 1,000 divided by 8. And when you do 1,000 divided by 8 out on your calculators, you get 125. So what that means is there were 125 bacteria 3 hours earlier. You could also say before the start, or you could say ago. -3 for this one means that it was 3 hours before that initial measurement was made of 1,000 when it started. When you plug in the number 0, f of 0 equals 1,000 times 2 to the 0. Remember, any number raised up to the power of 0 equals 1, so this number equals 1, and then 1,000 times 1 just stays 1,000. So there are 1,000 bacteria at the start, or you could also say at the beginning of measurement. And then the last one wants us to plug in f of 4. So f of 4 is equal to 1,000 times 2 raised up to the positive 4th exponent. Let's see, 2 to the 4th is 16, and then 1,000 times 16 is going to give you 16,000. So there will be 16,000 bacteria 4 hours into the experiment. You could also say 4 hours after the start of measurement. What this is trying to help you see is that you can use an equation and plug the numbers in. It also helps us practice what we've been learning about in this section with the negative exponent. But the last thing to take away from this is that when something's growing up by a doubling amount, or when something's going up very quickly, in this case it says it doubles every hour, these kind of exponential functions get big very quickly. It went from 1,000 to 16,000 in only 4 hours. And so we're going to be looking at problems like this in this new unit that talk about exponential growth and how quickly something can get big when it's increasing exponentially.